So good morning, everybody, and welcome back. If I could start just by asking our speakers for this first session to come and join us up here on the stage. So Cameron's here. Hi, Cameron. Tassos, Derek, Ross, Asper, and Cindy, if I could invite you all to come and join us here. And we're going to be getting started then very shortly. Thank you. Mike's coming as well. So. Yes, he's online. Yeah, he's there now. So that's all good. So yeah. Okay, did you want to come and sit here? And then this will be here again.
Yeah.
So the questions are virtual questions. So.
Thank you.
I think whenever you're ready,
I don't think it matters too much in terms of. I think you can take whichever seat really, and either kind of present from set down or come up to you up to you, and just show everyone again. If anyone's got slides, green button there.
Just quickly, guys, mics are already on. I haven't muted, so turn the mics off. Yeah.
Nice. Good morning, everybody, and a very warm welcome back here to day 2 of this year's 6G Global Summit. So great to see so many of you here again in Ottawa, and as well, as I said yesterday, a very good morning, good afternoon, or good evening, wherever you're joining us from around the world. I think we had almost 400 people virtually joining the platform yesterday, and hopefully we have many of you back here again for day 2 of the event. And great as well to see so many of you here in Ottawa. Really interesting day yesterday, really good discussions yesterday, and looking forward to another 2 sessions that we have left this morning to continue the discussions on that. Just before we get started, a couple of things to mention. First of all, for those of you here, there is Wi-Fi available. Anyone who wasn't here yesterday, and can we bring the slide up? Thank you very much. So you can see the network and the password you need to use the Wi-Fi here. So anyone here who hasn't yet logged on, you can use that to log on to the Wi-Fi. There is also the password and details available out on the desk if anyone doesn't get that in time. And when you are online as well, just a reminder that you have a QR code at the bottom of your badge. That QR code can be used to download all of the conference presentations that were made yesterday. You can view the agenda and other details as well, so please do use that there. For those of you joining virtually, as yesterday, we want to invite you to please contribute to the discussions. We want you to add your questions. You can use the Slido tab on the right-hand side of your screen to add your questions, which will then be passed over to the moderators for each session, and we'll be bringing those up in the sessions as well. And for you, the conference proceedings are also available on the left-hand menu bar, the icon at the bottom of the menu. You can use that to access all of the presentations from yesterday, and also the presentations from today will also be added onto that as well. Finally, before we get started, just a few thank yous again to the people and organizations that have made this year's event possible. First of all, a huge thank you once again to our partners here in Canada, to ICED, who have been the perfect hosts and really have been looking after us, and I'm sure everyone else here as well. So really do appreciate that. So yeah, thank you so much to ICED, and also to all of our sponsors and partners. So you can see all of the different organizations who have supported this event on the banner behind us here. Really do appreciate the support of each and every one of them and what they've done to make this possible. So thank you very much to all of our sponsors and partners as well. Okay, so we only have half a day today, 2 sessions, but we have a very busy morning, so keen to get going. So we're going to be focusing on specifically the spectrum and connectivity of things, side of things today. So we look maybe more generally at issues around standards, AI, and how that's been interacting with 6G yesterday. Today, this focus is going to be specifically on that connectivity side, and delighted to have 2 sessions looking at that from different angles. So session 6, which is going to be after the break, we're going to be looking at how maybe the connectivity ecosystem is going to be changing as we move towards 6G, the interaction between different technologies, different ways of getting online, licensing and things like that. But before that, we're going to be looking at the 6G spectrum roadmap, looking at maybe what are the key bands that are emerging that are going to be the bands that are going to really push forward and drive forward 6G. So really interesting discussion, and looking forward to hearing from our panelists on this. So we have, again, a fantastic lineup of speakers to discuss these issues. And we also have Cameron back again. So we're working you hard this year, Cameron. So great to have you back. And I'll pass over to you to lead the discussion. So welcome, over to you.
Okay, brilliant. Well, thank you very much, Dan, and thank you everyone for coming back for the second day today. So as Dan said, what we're going to be looking at in this session is going to be 6G spectrum and roadmaps for 6G spectrum going forward. And I think what we're really going to try and look at is, as we kind of move forward to 6G, is the kind of previous model of new spectrum for different generations, harmonized bands globally, is that achievable and realistic going forward? And, you know, what level of harmonization can we achieve? So we're going to be looking at, you know, how that's coming under threat from conflicting demands from different services and conflicting priorities as we look around the world. And we'll also look at, you know, potentially how, as the world is developing, perhaps changing trends in traffic growth around the world, how that might affect demand for spectrum and this model of kind of harmonized pioneer bands. So as we go through the spectrum, we just through the session, we're just going to be looking at, you know, what level of harmonization is needed to enable the kind of device ecosystem to develop in 6G, you know, how we can enable greater flexibility, and we might also touch on the increasing role, for example, of spectrum sharing as we go forward. And obviously, as part of that, we'll touch on the WRC-27 process and the specific bands that are being studied there potentially for 6G use going forward. So that is the kind of overall aim of what we're going to discuss today. I'm joined by a kind of team of very distinguished panelists, and we're going to adopt the same overall approach as we did during the panels yesterday. So each of them is going to give a kind of 5-minute introduction outlining their view on 6G spectrum and how things are developing in that regard. And then we'll jump into a panel discussion. Obviously, I will kind of lead that discussion, but we'll also be very pleased to kind of bring in questions both from online and also from in the room. So with that, I'll hand over to our first panelist to make their introductory remarks. And we're going to start off with Tassos Loratsis from RSPG, who's going to give us a bit of a European perspective on 6G spectrum roadmaps. So Tassos, welcome.
Thank you. Thank you, everyone. Really happy to be here. Good morning. Thank you to Forum Global for inviting me. I'm working in Athens, Greece, for the regulator, and I'm also working in the RSPG in the European Union, which is an advisory group to the European Commission on spectrum matters. So we started with the roadmaps back in 10 years ago with 5G, and that first opinion from the RSPG was well regarded because it set a clear path for spectrum and what were the bands that would be assigned to 5G. It was well received by manufacturers and operators because they had a clear, let's say, roadmap on what to develop and where to focus on that. So in last year, the RSPG was asked to do the same for 6G in order to produce again a clear path for spectrum bands that would be used for the new technology. So the draft opinion was in consultation during February and March. We received something like 40 plus comments and responses from stakeholders. And the final one is expected to be published in June, so next month. Focusing on spectrum, the RSPG notes that there is already 1 gigahertz of spectrum in low and mid bands assigned to operators. And we truly believe that the new equipment, 6G technology equipment, should work with this existing spectrum. For launching 6G, we have named a new band, the upper 6 gigahertz band, as the pioneer band. This provides at least 540 megahertz of spectrum in the mid band for achieving connectivity and coverage, mainly in urban dense areas. And the exact frequency range, at least for Europe, will be decided after WRC 27. This is because WRC 27 will also examine the possibility of assigning the 7125 to 7250 megahertz band to IMT as well. So this could complement the upper 6 gigahertz band. We also have the millimetric wave bands that have not been used up to now. One of them was also named as a pioneer band for 5G, but no equipment, no real business cases, and this is quite underused. For verticals, we have said that the 3.8 to 4.2 gigahertz band can help develop low power or medium power local networks for private use. So this can help verticals employ 6G technology for their needs. Finally, the UHF band, which is widely used for television broadcasting in Europe, has been allocated to the mobile, except aeronautical mobile service on a secondary basis. And based on the results of studies from ITUR, the WRC 31 could review the allocation of this band so that the 600 megahertz band could be allocated to IMT. So this will enhance 6G technology. This will help 6G technology to achieve coverage in wide areas. That's all for spectrum in the opinion. Apart from those points, the opinion also includes other aspects like sharing, sustainability, the interworking of terrestrial and non-terrestrial networks, and the interoperability between mobile and fixed networks where wireless LAN play an important role. That's all for introduction. Thank you very much.
Brilliant. Well, thank you very much, Tassos. And straight away then we'll move on to our second panelist to make their introductory remarks. And that's going to be Derek Clopin from NTIA in the US. So Derek, please.
Take the podium option. Good morning, everyone. Great first day yesterday. I appreciate the opportunity to once again join a session here. This time focused on spectrum roadmaps in the context of 6G. It's become cliche to say that spectrum is the lifeblood of mobile networks, as it is for many telecommunications and other radio-based services. But I think it's okay to say it because all of us in this room know it's true. So an operator refarming existing licensed spectrum holdings and implementing improvements in technology can increase spectrum efficiency and maximize the utilization of spectrum resources. And this can certainly help somewhat in meeting the additional spectrum requirements we expect from 6G. But I can tell you that at least in the United States, policymakers have determined that will not be enough. As I mentioned yesterday, and many are aware, the US Congress and the President have already decided that the US must and will make additional spectrum available to support wireless broadband, or 5G and 6G networks. Last summer, the US Congress passed and the President signed the Working Families Tax Cut Act, which included provisions that direct NTIA to identify 200 megahertz of spectrum within 2 years, so that's by next July, then to identify another 300 megahertz 2 years later, July 2029. All the while, the FCC is to auction a total of 800 megahertz. And the law said that this spectrum pipeline must flow from spectrum in the 1.3 to 10.5 gigahertz range. And then it further laid out which current federal government used spectrum bands we need to study. And this was 2700 to 2900, or shorthand, the 2.7 gigahertz band, the 4 gigahertz band, 44 to 4900 megahertz, 71 to 25 to 7400 megahertz, or the 7 gigahertz band, noting that the legislation in the United States domestically took 74 to 84 megahertz off the table through 2034, again, just in the domestic scope. The president then doubled down, was winning the 6G race, presidential memorandum, and that recognized that not only do we need to do this spectrum repurposing effort, we need to do it faster, and we have to succeed. He directed NTIA to immediately commence studies for the lower 7 gigahertz, and by the end of 2026, submit a report to the White House, directing us to begin the process to identify the lower 7 gigahertz band. So I think we can confidently say we're on track, and it's not so much an if anymore, but a when and how we do it. The president also directed us to begin the process for studies of 2.7 and 4.4. So we've been working hard on those bands, including through NTIA's chairmanship of what is called the technical panel. This is the tech panel, which under the law reviews incumbent federal agency study plans for funding eligibility to perform these technical studies. So the FCC, NTIA, and the Office of Management and Budget in the White House sit on that panel. And the rationale there, of course, is that these federal agencies, they do not have appropriated funds, money to study spectrum. That's not what they do for a living, right? So this is supplemental funding to allow us to form those studies in conjunction with the agencies. 7 gigahertz, as I noted, is well underway. That study we do by the end of the year. 2.7, we've sent the study plans to Congress under the law for a brief final step, a rating period. And then we're working the same progress for the 4 gigahertz band. And that band, of course, aligns with 3GPP band N79. 4 gigahertz has not been a major study focus for the United States in recent years, so we know this one's going to take a little bit longer. There's about 9 incumbent federal government users, but again, we're not too far behind there, and we're going to push it as well too. In addition to the bands and the legislation, the president also identified, we're also studying 1675 to 1695 megahertz in the L band, potentially also to include for direct-to-device satellite services. So at this point, we can't say how much we're going to get, but we're pretty committed to meeting or even exceeding those statutory targets we have. And the bands we're studying does not even consider the upper C band that the FCC is going to auction next year. Now, once we resolve the concerns with the potential interference to nearby radio altimeters, that's on track as well. We've been kind of calling this we think a sort of U.S. gift to the world to make that available, because again, all these aircraft that traverse the United States are going to have to make those upgrades. So again, we need to make significant portions of these bands available. But again, we know the efforts don't stop at our borders. The U.S. is committed to leveraging our intensive domestic work on these bands to help harmonize spectrum allocations globally so 6G can proliferate. WRC Agenda Item 1.7 is the IMT agenda item this time. There always seems to be an IMT agenda item, right? 4 gigahertz, 7, 8, as well as 14 gigahertz are part of that. Like many other countries, we haven't finalized our position on 1.7 yet, but I can tell you that we'll be supporting IMT allocations in these bands. We believe these bands and the 3 gigahertz range that we already are enabling will be the workhorses for scaling 6G around the world. And as 6G becomes this network of networks, a true convergence of technologies, unlicensed or license-exempt technologies also play an important role, as do satellite and NTN. Wi-Fi to us is an incredible, remarkable success story. We all rely on it, especially almost every time we walk into a building like this one, right? So Wi-Fi at 6 gigahertz is exploding, and we expect additional countries to continue joining those already allowing Wi-Fi across all or most of 6 gigahertz. And then finally, just to add to this competing spectrum demands is the burgeoning space sector. NTIA has been collaborating with the FCC to enable additional spectrum access for satellite systems. A lot of NGSOs in particular, through the Commission's rulemakings and approval of applications from them, among others, Starlink, Amazon Leo, AST Space Mobile. So broadband connectivity, D2D, the FCC's own words, they are pursuing making over 20,000 megahertz of spectrum available for satellite broadband to support next generation connectivity, so the U.S., to maintain U.S. leadership in the global space economy. And to be clear, that spectrum's certainly not all exclusive. Most of it is shared, but I could go on, but over my time, so I'll leave it there for now.
Okay, brilliant. Well, thank you very much for that, Derek. And next, we're going to hear from Ken Sit from the OFCA in Hong Kong, who's joining us virtually today. So, Ken, over to you.
Thank you. Here's my slide. Okay. Good morning, Mr. Kurin, fellow panelists, ladies and gentlemen. I'm honored to participate in this event today and to share with you the experience of spectrum supply and spectrum planning for 5G and the future 6G in Hong Kong. Next slide, please. Okay, 6G will provide a brand new user experience through artificial intelligence and communications, ubiquitous connectivity and integrated sensing and communication to realize the full experience of 6G spectrum in low, mid, and high band are required. Next slide, please. The ITU, International Telecommunication Union, has outlined a roadmap for 6G. It is anticipated that additional frequency band identified for international mobile telecommunications at Award 23 and the upcoming Award 27 will gradually be implemented in the following years to support 6G that will be deployed from 2030 onwards. Next slide, please. And Award 27 will discuss the candidate bands for terrestrial mobile services, in particular the 4.6 gigahertz, 7 or 8 gigahertz, and 15 gigahertz bands. And also, Award 27 will also discuss the candidate bands for non-terrestrial mobile services. ITU and many regional organizations have been playing an important role in global spectrum harmonization and coordination. Next slide, please. Next slide, please. Okay. In Hong Kong, 5,100 megahertz of spectrum have been made available to the market, and over 3,600 megahertz of spectrum in low, medium, and high frequency bands are already been assigned to the relevant mobile level operators for the 5G in Hong Kong. Next slide, please. Regarding recent spectrum supply in Hong Kong, the 6,425 to 7,125 megahertz band, also known as the upper 6 gigahertz band, is the largest part of the existing mid-band spectrum. That can be made available for provision of public mobile services. Hong Kong is the first in the world to conduct a spectrum auction in the upper 6 gigahertz band in the late 2024, and in March 2025, 300 megahertz of spectrum in this band was assigned to MNOs, the operators for 5G and even the future 6G. Besides, Hong Kong has recently completed the auction of the 2.6 gigahertz band for spectrum reassignment. Given the technology neutral principle, our operators, the mobile level operators, may refarm their existing spectrum being used by 5G or the 5G advanced services to further support the application of future mobile services, including 6G. We will keep monitoring the global spectrum development and continue to participate in various international forums to share Hong Kong's experience in spectrum planning and supply. Thank you.
Brilliant. Well, thank you very much, Ken. So now we're going to move a little bit away from the kind of regulators and move into some of the kind of industry stakeholders. So I think first we're going to hear from Ross Bateson from the GSMA, who's going to give the kind of mobile industry perspective on 6G spectrum.
Thank you, and good day to everybody who's enjoying the lovely weather in this beautiful city. I've just got a couple of points to make today on the spectrum side of 6G. I want to talk a little bit about why we're talking about spectrum, what the traffic situation is in sort of fairly simple terms, and then talk about some of the solutions that we might be able to find to it. Yeah, thank you. So it's been a pleasure being here in Ottawa and being sat between these amazing, famous rivers of the St. Lawrence and the Ottawa River that have been added to over the years by human manufacturers like the Rideau Canal and then turned into the St. Lawrence Seaway. And why did all these great channels of communication need building upon? Because there was more traffic needed, more trade needed. And we've sat here talking about a lot of the futuristic applications of 6G this week, about robotics or ISAC or any of the applications that we think that will become embodied by the 6G era. But I want to talk about traffic growth in much more simple terms. When people get better access to connectivity, they start using it more. When people can use their phones when they sit down on a train in a busy logistics hub, travel hub, train station, they can download video. When we have better quality of service, we can access more complicated ways of viewing media. The fact that people like watching stuff is nothing really very new. That was discovered in the 1940s, 1950s. The fact that people like watching stuff in a more lifelike manner is nothing new. And that was true with color TV in the 70s or digital TV in the 2000s. These are the basic premises driving traffic growth, and we're seeing that today. We talked a lot about, yesterday about 5G being problematic somehow. 5G hasn't worked. That's not true. We'd be in an awful lot of problems today if we didn't have the efficiency of 5G driving our current networks in busy areas. And that'll become true of 6G. At the GSMA, we believe that if spectrum is constrained to today's levels and on the same systems, we're going to have problems in 50% of the world's urban areas by 2030. We need to do something to relieve the pressure on capacity that's been created by the fact that people like using their phones, people like watching stuff, and the better quality of service you give to them, the more they do it. Between 10 and 20% a year growth in most major economies. That's like doubling every 3 or 4 years. So where do we go to deal with that? I don't think this will be unfamiliar to you, and just a quick progress report on where we believe we are on the critical bands. We're seeing lots of 3.8 to 4.1, 4.2 discussions happening again. That's really useful. Obviously, that's spectrum with a really good ecosystem already. So long may those discussions continue. Do we want to raise that at WRC again? I don't think we do, but the ecosystem is there, and I hope that countries, as we've heard from the US, for example, recently, will continue to look at ways to exploit that spectrum. The 4.5 gigahertz band, how is that going to go? I think it's clear that there are some countries that are very keen on this band. There's other countries that are not keen on it. And both with 4.5 and with 7 gigahertz, we speak to countries who find these spectrum bands problematic. But the fact is that in both of them there has been movement, and both of them there has been that there will be, or in the case of 4.5, there are already IMT systems. And then briefly looking on to 7 gigahertz as well. Well, we're in year 3 of the WRC cycle now. And after each WRC at the GSMA, well, first of all, we sit down and say, right, we can get on with something else for 6 months before we have to worry about it too much again. And then about a year in, we start looking around and wondering who are the people supporting the different bands will be. And sometimes that can be quite lonely. We're in year 3 now, and that's not lonely at all. We're seeing very, very significant scale supporting the 7 gigahertz band now, to the extent where you can confidently say that this is going to be used for IMT in the future. So the question is, for all your difficulties, what's the limit of your resistance to this, or are you going to support the band because you see in the future that your operators want the kind of channel size that's indicated by the lines on my slide now, 200 to 400 megahertz channels to optimize performance in a 6G environment. How are you going to get to those channel sizes? Well, if you're not looking at that bottom chunk of spectrum between 6 and 8 gigahertz, it's going to be really, really tricky in a lot of countries. So this is why we're seeing that scale. I think the extent of 7 gigahertz is still going to be discussed, but I think it's very, very clear that 7 gigahertz will become an IMT band, and we look forward to everybody joining us on exploiting that spectrum fully to deliver the economic growth that we need in the 2030s. Thank you.
Brilliant. Well, thank you very much, Ross. So next we are going to hear from Asper Paroutsas from Qualcomm, who's going to give us more of a kind of chipset vendor perspective. I think hopefully he just needs to unmute it from over there. I think.
Okay, here we are. Thank you. Good morning, everyone. We heard both yesterday and earlier from my colleagues about 6G and why that is important, and about spectrum and how the different regions are thinking about it. But what I'd like to focus is why this spectrum roadmap is really important for the adoption of 6G. 6G is not just the evolution of 5G. It is a foundation, is the foundation of an AI-driven global economy, and that is because it provides a high-performance connectivity layer that will allow for the intelligence to go across from the device to the edge and the cloud. And here we are. And for 6G to be a success, we need to have timely access to wide contiguous licensed spectrum, both combined with innovation across the network and the ecosystem. We expect the global mobile data usage to increase threefold by 2030. That will be driven by AI services and content, by XR and immersive applications, and video streaming, as well as cloud computing. Data traffic per connection is growing about 19% average yearly. This reflects a fundamental shift from human-generated traffic to machine-generated and AI-mediated traffic. And the structural shift is in network requirements, which also translates in spectrum requirements. Now, 6G is the first wireless generation that is designed with AI in mind, with AI as being the primary workload. And the 6G network will be an AI native network. In effect, 6G will enable tiered AI inferencing on device, on the edge, and in the cloud. It will connect a much broader ecosystem of AI-enabled devices. That means we're moving from this idea of the network supporting just your smartphone, and we're going to have more wearables and cars and robotics that will depend on this layer of connectivity. As a result, we expect by 2034 the global WAN traffic to grow between 3 to 7 times, and AI traffic will be approximately 30% of this. This is not just incremental. This growth, the growth in existing spectrum pipelines are not currently sufficient to meet the projected traffic loads without the provision of additional spectrum. So as the AI it becomes the new user interface and the increasing mobile data demands the mobile demands are increasing, the capacity challenge is real. A single XR use case can exceed 19 gigabytes per month, which is the average user baseline. With advanced use cases, we will need then a higher uplink capacity, low latency, somewhere between 10 and 30 megabits, a sustained throughput. And that basically means that we are going to have to move from 100 megahertz channel to much larger channels of probably around 400 megahertz. That will allow for more users to be on a cell, and all of those users have more demands out of the network. In closing, I'd like to urge the policymakers in this room, but also online, that it's very important to ensure that the timely identification of bands per the conversations we had earlier, whether those are the ITU bands that we discussed or regional priorities for the adoption of 6G. We also need sufficient large contiguous license spectrum to become available. And let's not underestimate the importance of global alignment when we make these decisions. The choices that we will all make on spectrum will determine whether we can fully realize the promise of an AI-driven connectivity in the 6G era. Thank you all.
Brilliant, thank you. And finally then over to our final panelist for today, which is going to be Cindy Cook from Ericsson. So Cindy, over to you.
Thank you, and thanks to Global Forum for the opportunity to speak, and to ICED for partnering on this event. I'm going to be talking as well about the 6G spectrum roadmaps and some strategies from an Ericsson perspective. There's probably a lot in my slides that has been discussed so far in the last couple of days, and where I know we've had lots of discussion already on some items, I will skip quickly through those. But taking a look, and I think there's been also lots of discussion on some of the types of use cases that we are going to see, and the reason why we're looking for additional spectrum for 6G. So as we transition from 5G Advanced to 6G, this is going to be marked by moving from networks that have AI or work with AI to networks that are AI. And we're going to see a world with the emergence of AI native use cases. So Gen AI enabled smartphones, XR devices, eventually supporting holographic communications, AI autonomous droids. All of these are going to be possible use cases that will impact traffic volumes and the required network characteristics, such as quality of service and latency. All are going to depend on high-performing connectivity in both outdoor wide areas and indoors. And I think ASPA just did an excellent job of explaining why these are going to impact also the channel sizes that are going to be needed as we move forward. These are all going to need access to the right kind of spectrum, preferably harmonized, under the right technical and license conditions if they're going to be successful. So although some of the use cases in the previous slide are being demonstrated today, this is one of the points I wanted to make, because I often hear people say, oh, but we can do XR, we all have you can get Meta glasses now. Why do we need 6G? Well, very few of us are wearing Meta glasses right now. Very few of us have XR devices. There are a few lucky people who are the initial ones who try them out and talk about how wonderful they are. But if we're going to scale that, if I'm going to come back here in the 6G timeframe and look around the room and 20% of you are going to be wearing those, that's a lot more traffic on the network than if only one person in this room today has those. So the additional need for spectrum is also driven by the fact that these new applications that we see coming out, these new use cases, need to scale. And if we're going to scale, we need that additional spectrum. The GSMA has, in their Vision 2040 document, said that we're going to need an additional 1 to 3 gigahertz of spectrum for wide area spectrum needs. And that's part of the information that's on this slide, and I won't go through too much more that's there. Taking a look at timelines, because when we look at roadmaps are all about what spectrum are we going to make available and when. We need to look at the industry 6G timeline. So here we have one of the diagrams. There's been several that have shown. The most important thing to point out here is that the 6G standards are on their way. We expect the functionally frozen ones to be, I think this has already been mentioned before, at the end of 2028, the spectrum decisions at WRC at the end of 2027, and initial networks to be deployed in 2030. There will certainly be some early networks demonstrated before then. This one, because I also realized that my time just reset. Look at that, I was like at a minus and now I'm back at a plus. Oh goodness, okay, good. I thought I was running out of time. So this is what Ericsson likes to call our cake diagram because it looks a little bit like a wedding cake. But here I just want to point out that 6G is going to operate in all spectrum. It's going to have the capability to operate in low, mid, and high band. The initial deployments are being looked at in centimeter wave and in mid band. So in the 6 gigahertz, upper 6 gigahertz band for those who have it, 7, 8 for those who don't have upper 6. It's going to be extremely efficient. It will be spectrum aggregation is going to be possible, and I know a lot of people say, well, with MRSS we can move our spectrum from 5G to 6G, and yes, that's going to happen eventually. But for that initial launch of 6G, we're looking at clear wideband spectrum in order to have those benefits, in order to see that vision of 6G fulfilled when it is first launched. Then this is just to show you some of the bands that are being looked at for 6G at the moment in kind of the mid-band and centimeter wave range. In the middle is the upper 6 gigahertz. In some countries that is unlicensed, is in the US and Canada. We just heard from Europe as to their plans, and from Hong Kong as well. And there are other countries like India and China who have also decided to already allocated this to IMT. So as we, the identifications that were made at the last World Radio Conference cover about 80% of the world's population. And so this is going to be an important band. But for those countries that don't have access to this band, and for future 6G deployments, the 7-8 gigahertz band will be key because, as many people have said so far, this is where we're going to be able to find those 200 and those 400 megahertz contiguous bandwidths for 6G. Eventually, as people start moving their 5G over to 6G, we'll be able to use MRSS to do that in additional bands. I've also added here the OB3A bands, to show where the US is looking for additional spectrum. And I think Derek's already covered a lot of that, but for completeness, this too are frequency bands that are being looked at for their future networks. And then now I am in the minus time frame, but I'm at my key takeaways. So I've made these points already, but just to note that we're looking at AI native and capacity demanding 6G use cases that are going to drive our traffic volumes. and the network characteristics that are going to be needed in order to accommodate those new use cases, that 6G is going to need additional harmonized wide area spectrum beyond what is available today. That the key bands, I just went through those, the 7, 8, the upper 6, and then the low bands in order to have coverage and support digital inclusion. And that leadership on this path to 6G includes, in order to get to 6G, we have to have 5G advanced networks. They will pave the way. We need to have new clear spectrum available for those initial 6G launches so that we can see 6G launched in the vision that we have for what it can do. And then identifying future spectrum for 6G from the WRC and OB3A frequency bands. Thank you.
Okay, brilliant. So that's the introductory remarks from all of our panelists. So we'll move on to the kind of panel discussion now. And just to kind of kick off that discussion, picking up on what you were saying at the end there, Cindy, about the importance of different frequency ranges. We're seeing obviously a big focus on the mid-bands in the kind of upper mid-band, shall we say, in the 6-7 gigahertz range. So what do we see in terms of the potential role of those centimeter waves, 14, 15 gigahertz? Is that largely dropping off the agenda? Could there be a role for the existing millimeter wave bands increasing their role in networks as we move to the 6G era? Would anyone from the panel like to kind of comment on that? Russ?
Sure. Very, very brief. In fact, I think we're seeing strong commercial interests going up to the 7 to 8 gigahertz range. We're seeing limited commercial interest in 15 gigahertz, thinking that the characteristics are much more similar to the millimeter wave bands that are already identified for IMT. So we are seeing some processes to get 26 gigahertz out to market. And we've had a successful one concluded recently in the UK on millimeter wave. That's there to cover sports stadiums and transport hubs, this kind of places, and obviously for enterprise as well. There's plenty of millimeter wave available, and we're looking at less enthusiastically at 15 gigahertz as WRC.
Okay, I think that's a very clear position then. So if we come down then into the focus area of the mid bands, and particularly the 6 and the 7 gigahertz. Obviously, we've seen some divergence internationally in terms of the upper part of the 6 gigahertz band. And I guess perhaps, Derek, it'd just be interesting to get your view on, how that might drive divergence as we look forward to 6G, and whether that presents some challenges for the US given the allocation to Wi-Fi and unlicensed use.
Thank you. Appreciate the question. As I said during my remarks, the United States is very committed to maintaining, the Wi-Fi across 6 gigahertz, and we're seeing the, aggressive deployment there. I mean, I think our view is generally it's a little, early to say you're going to, miss out not having IMT there. We're still very confident in what's going to happen in 7 gigahertz, 3 gigahertz, possibly 4 gigahertz. So I think there's a lot on the table. And to be fair, if you think about IMT deployments in 6, they're not really happening yet. So I think there's a lot to play there. We're also seeing some interesting, I think a number of countries who are taking a little bit more of a wait and see approach, and thinking about, exploring potential options too, where you may end up having more sharing between unlicensed and licensed in those bands, indoor, outdoor type of things, and, waiting to see the results of WRC and see what happens there. So again, I think it's early to say. I don't, I think I'd probably reject the notion that we're going to, miss out on the ecosystem there, because we do think, at the end of the day, the United States is going to make a lot of spectrum available across those bands, and we do think there will be a lot of countries doing similar. Thanks.
Perfect. So perhaps, Ken, if we might bring you in on this point, given that Hong Kong has obviously taken a leading role with the 6 gigahertz, given that kind of availability of the upper 6 gigahertz, how do you kind of see 7, 8 gigahertz developing in Hong Kong?
Actually, we think the upper 6 gigahertz band is the more important frequency band for 6G because which is the largest remaining single broad of existing mid-band spectrum for mobile services, which will enable the deployment of 5G and the future 6G networks and services with speeds and capacities. And VGPP has already developed a specification on radio frequency characteristic of this band for both network and user equipment, and a number of equipment manufacturers have also confirmed their readiness to supply equipment supporting this frequency band. Besides, the upper 6 gigahertz band has been identified for IMT at the Ward 23. So I think we think the upper 6 gigahertz band is important frequency band for the 6G. We also observed that the development of the upper 6G band for IMT has been gaining momentum over the past few years. An increasing number of administrations have identified or are considering the identification of this band for IMT, like even some telecommunication regulators or advisory groups are proposing prioritized use of part of this upper 6 gigahertz band for IMT, or even shared use of this band between IMT and Wi-Fi at different geographical locations. This development actually highlights the critical role of the upper 6 gigahertz band in 6G spectrum planning and deployment. Actually, in Hong Kong, we conduct the auction of radio spectrum in the upper 6 gigahertz band in November 2024, and assigned a total of 300 megahertz spectrum last year. Actually, the upper 6 gigahertz band may be used for 5G advanced or even the 6G. Make Hong Kong as a fast mover in releasing this important band for the 6G development. So I think we will more focus on 6 gigahertz band up to this moment. Thank you.
Perfect. Thank you very much, Ken. So I guess this conversation serves to illustrate to some extent the differing national approaches and some level of fragmentation internationally. So building on that, I just wanted to kind of ask the panel a bit about what level of harmonization do we need to see within 6G spectrum roadmaps in order to develop that kind of device ecosystem, achieve the economies of scale? And perhaps some of our vendors would like to come in on that point. What level of harmonization in spectrum do we need to see to enable those kind of economies of scale?
I think it's very important to have harmonized spectrum around the world. And we do see now almost two camps as they see 6G, as you noted, with the upper 6 in a lot of parts of the world already being allocated in WRC 23, and some of it will probably be allocated WRC 27, and the 7-8 gigahertz band. We believe it's important as vendors, manufacturers, to have that harmonization. It allows for economies of scale, which allow for lower costs, both on the network side and the device side, a much more robust ecosystem of devices, and of course, services and interoperability across borders. So I think it's very important, no matter what we choose, that we have enough bands that we can include in our devices and that network so we can achieve all those results.
That's great. And yeah, Cindy, if you'd like to comment as well.
Yeah, thank you. So I was going to leave the device part to ASPA. From the network side, though, I think also important is knowing what the timing is of those. And if we're focused on harmonized bands, then we know that we're going to have equipment available for everybody at the same time, and that that will allow for very robust networks to go out. It'll also help, as ASPA already mentioned, with economies of scale with roaming, et cetera. I mean, also, we do recognize that it's becoming much more difficult to have globally harmonized spectrum. I mean, that's been obvious with the upper 6 gigahertz. We're seeing it in preparations for WRC 27. We also see that there is the possibility, though, of, you'll see in the IMT footnotes, it often says this band or parts thereof is identified for use by. So from our perspective, one of the points we're trying to make now is that even if we recognize that the 70 gigahertz band is going to have some pockets that are difficult, but that varies. And if the identification is for the whole spectrum, then administrations can work with that and determine which parts of it work best for their country. But it also allows us then to develop equipment that can cover the whole range. The identification of all of it is important, and then we will work with everybody to see what works best in their country or their region.
Okay, interesting. So then to move on to a slightly different topic from there, I guess obviously we're looking at the harmonization of spectrum, new spectrum for 6G, potentially exclusively licensed spectrum. But obviously as we go forward, there's increasing demands for spectrum, not only from mobile, but also from various other use cases. So do we see an increasing role for spectrum sharing, potentially dynamic spectrum sharing in the 6G era? And, what are the main challenges to that at this point? I don't know if perhaps Tassos, you'd like to come in on that point.
Yeah, thank you for this. We are very pro sharing. It's quite essential because spectrum is scarce. We all know that, and the demands that are forecast for 6G and new technologies and other applications, not only mobile, for consumers or industry, are really rising by the day. So sharing, yes, of course we are advocating for this, but is it feasible? If I was asked this question maybe 2 or 3 years ago, when all the studies were starting about sharing the holy grail of the last years, upper 6 gigahertz between wireless LANs and mobile, I would be more optimistic. But studies, at least in CPT, showed that there can't be sharing mechanisms that could keep both communities, let's say, happy. There was a quite long discussion, and maybe you could call it fight, between limiting power of one or the other technology, or containing indoors, outdoors, different technologies. So is it achievable? We are talking about the spectrum in the mid-band, which is very, very, very important. I totally agree with that. But for Europe, we are in a very difficult place, because all this essential, as you call it, spectrum in between 7 to 15 gigahertz is already occupied by quite critical services like defense, Earth observation, radio astronomy, which are quite sensitive and have to be protected. I could see local deployments for sharing. So in, let's say, more in areas where the mobile networks would not interfere with existing services. But for nationwide and national, let's say, licensing, what we are discussing in Europe is really, really difficult to achieve. So I don't know who will take the, let's say, the initiative for building or trying with new mechanisms for sharing that are robust and can, let's say, securely see that incumbent applications are protected. It's something to see for the future. I really don't know if we can achieve that.
Okay, interesting. Perhaps Ross, did you want to come in on that from the kind of industry side?
No, thanks. I totally agree with Tassos's review of how things have been happening. But I mean, sharing is a big word, right? I mean, we mean a great number of different things, and there's a great number of different ways of looking at this. Some old, some new ideas of DSA type sharing have been around for 20 years and never come to that much fruition. But I think one of the things that is clear is that we need to consider different dynamics in sharing, and we need to look at ways that it's been, I don't know, less popular, but so when you move to a sharing mechanism, that means lowering power on wide area networks. You reduce the economic value of that spectrum because it costs more to deploy, or the quality of service is lower, and sometimes that's been necessary. And very clearly, for example, in 3.5 in the US, the CBRS spectrum was held at much lower economic value than the non-CBRS spectrum, and that's not to say either way was good or bad. That's just the facts of the auctions that took place, because a clean, contiguous, full-power spectrum helps you deploy better quality networks more affordably, and that's really important. Sort of counterintuitively, sorry, that's the word I'm looking for. Counterintuitively, lowering power in networks also increases the carbon embodied in the network as well. So it stops us reaching our net zero ambitions quite so easily. So in a situation where increasingly the electrical supply is either from solar or from a green grid, a lot of the carbon embodied in a network is in manufacture. So if we're increasing the number of base stations in a low power environment, we're also increasing the carbon as well. So lowering the power is sometimes necessary, and no problem with that. But where that can be avoided, it's obviously has greater value. But we're moving into new discussions now, I think, and this is particularly relevant in 7 gigahertz, right? We have a lot of military users, a lot of government users in these bands. And what do we want to say about the possibility of a new environment there? Can we look at some geographic isolation? The places where mobile will have its highest capacity needs are relatively small geographic areas, and we haven't done them for everywhere in the world, but that's less than 10% of my home country, the UK, for example, would have these urban high capacity needs. Can we do some geographic splits, or can we have in a slicing and intelligent network environment a way of giving a super priority user in times of emergency for public protection networks or any kind of government and military networks? Can we accept as mobile operators that in an emergency there will be a time when our quality of service will need to be reduced to allow for the government network to move in? This is not a 6G concept of technology. This is something that exists today, but will the world become more comfortable with that in the 2030s? We'll have to see.
Okay. Thank you. And Asper, did you want to come in on this?
Yeah, I think both Tassos and Ross raised some very good points, and we need to make sure when we talk about sharing, we realize that there's so many different flavors of sharing. It's between different technologies, between different uses, between different users. It could be geographic or not. And it all depends on the priorities of each country and how they want to prioritize their spectrum needs, and they value the different uses. And from an engineering perspective, and as a company that has worked in a lot of different cross-technology sharing, we think that there are ways to move forward. But it is going to be a political decision most of the time of how do we want to use spectrum. And we'll have to see, because as Tasso said, it's a scarce resource, and we'll let the regulators determine how they want to make those decisions. For looking ahead for 6G, We believe it is very important that that spectrum is as unencumbered as possible in a license form that allow the operators to invest in that spectrum without lowering its economic value, as Ross said. And we just think that's a priority right now. Thank you.
So, yeah, thank you, Derek.
A lot to react there, and I think a lot of this comes down to spectrum sharing. As Aspa said, it exists today. It's widespread. A lot of it's less publicly known. For example, in the United States government, I mentioned before, we had 9 federal agencies using the 4 gigahertz band. Spectrum sharing amongst government users has been around a very long time, and it's actually quite fascinating. And they're all very disparate systems too, for some of that coexistence. But some of this, I think, too, becomes, if you look at, again, I know we've talked about the 6 gigahertz and Wi-Fi unlicensed, some of this is, I thought about this fear of missing out, and I think you phrased it as the US missing out on a 6G band, but I think what we're seeing too is a lot of countries realize they don't want to miss out on Wi-Fi there too for their consumers, right? So a lot of this is again, driven by the market, driven by regulators, but some of it just is very intuitive, right? I think I had one bar of cell service on my phone here, and so you want to have prolific Wi-Fi there. We mentioned the glasses. Well, that's great if you're out on the street, but if 20% of the people come in here with their glasses on and they want to roll on the Wi-Fi, you need serious capacity there as well too. So I think it all kind of works together. I think CBRS was a very interesting example, and maybe from a market perspective, it didn't bring the auction revenues, but on the other hand, the option was, well, then you don't get that spectrum, right? So, or at least in that timing, right? So it's an opportunity to keep some users in place. The other thing I think we're seeing in terms of government industry sharing is, especially, a big push in the United States is more government use of commercial systems, right? So I think the sharing becomes more natural where you start having commercial systems in these government bands, and the agencies can actually benefit from that and maybe start shifting some of their spectrum usage on the commercial systems. And that's a way to kind of start, I think, walking more in that direction. So I think it's inevitable. I think, again, we have a directive right now where we're doing all we can to find, exclusive licensed spectrum. And that's, industry often calls it the gold standard. And I think we, agree with that. But there are times where spectrum sharing is where we're going to need to go. Thanks.
Okay, perfect. So we're coming up towards the end of the session. So I'll kind of open this up to the questions online and obviously in the room as well. So online, we've got a question coming in basically about the lessons that we can learn from 5G when we're putting together 6G spectrum roadmaps, and particularly about the lessons that come out of the rollout of 5G in mid-band and in millimeter wave. So is there anyone that would kind of like to comment on, what went well in 5G, what perhaps didn't go so well, and, how that feeds into 6G? Thank you. Tassos.
A first remark, and I would like to quote something that I heard yesterday about 5G, 6G, or whatever G comes after that. We should not regard it as a race. So what was also mentioned, I think 2 or 3 years ago in the 6G Global Summit in London, was that if we did not race to launch 5G in 2020, maybe delaying it for, 6 months, 1 year, 5G standalone would be achieved when launching 5G. So the lessons learned is we should better have, let's say, mature technology and not racing just to make, some announcement that we are first in this or better in that and things like that. I know that advertising and marketing people really like making labels, 6G that, 6G though, this thing, and new technologies. But for us engineers, I think that we should be better, let's say, more reflecting on what we can actually achieve and sacrifice some time, the timelines, in order to achieve a better solution, a better deployment.
Perhaps, Ken, would you like to come in on this, given Hong Kong is a leader in terms of spectrum availability for 5G? Have you got anything you'd like to add?
Actually, I would like to make some comment on what we learned from 5G with respect to spectrum roadmap. Actually, what we learned from 5G is the importance of early and sustained international collaboration to minimize spectrum fragmentations and frequency coordination with neighboring administrations. To facilitate 6G development, relevant stakeholders, including the international organizations, equipment manufacturers, standardization bodies, mobile level operators, etc., should work together to harmonize the radio spectrum, the formulate telecom standards and telecom recommendation to facilitate the coexistence of flexibility between 6G and other services. Regional harmonization is also important and can create a more predictable ecosystem for manufacturers to develop radio equipment supporting 6G. That's what I comment. Thank you.
Brilliant. Thank you, Ken and Asper.
One thing I want to add about the spectrum side of all of this is what we learn in 5G is that mid-band spectrum is really important. So I think what we should focus going into 6G is focus on making the bands, the mid-band bands available as the pioneering 6G spectrum. And we can start from there, and then the networks can slowly come up to becoming 6G from 5G. Why is that important? Because that impacts the deployment costs, of operators. So if you go further towards millimeter band, you need more densification. You don't get the same type of propagation. So mid-band spectrum is really important. And I think we found out, at least in the United States, that is the case.
Yeah. Okay. Brilliant. Yeah, yes, indeed.
Just to add to what the previous speakers and ASPA was talking about in regards to spectrum and not making this race to 6G, I think it's important that rather than try to be the first one out there with 6G, that we ensure that we have the right framework in place, the right spectrum roadmaps in place, and that we have the right spectrum available to put 6G into. So I like to try and explain to people sometimes, well, imagine that the standards that are being developed for 6G right now are the architecture and the design of a house. So if the standards are your house, and then all of the use cases are the things that you're going to do inside of your house. Perhaps you're going to design your house is going to have very large rooms so that you might want to turn one of those rooms into a movie room or whatever. The house and the design of the house is fantastic, but if it doesn't have the appropriate land to sit on, if you don't give it land that is large enough for the house, that has enough space for the house to sit on, that is solid enough for that house to sit on, that is clear so that the house can sit on that without tilting one way or another or trying to avoid something else that's on a tree or whatever that's on that land, then it's not going to be exactly what you had envisioned. So I think of that land as the spectrum, and we need to have the best spectrum, the clearest and the most appropriate spectrum for that 6G house to sit on.
Perfect. Thank you. And yeah, I'll just open it up to the audience. I think, was there a question down here? Sorry, one in the back corner. Sorry, you're just behind the podium from me.
Thank you. My name is Corey Mandrick, and it's been an enlightening 2.5, 3 days here in Ottawa. I appreciate the gathering of all of this knowledge. It's been wonderful to absorb. In regards to spectrum and the expansion of unused spectrum, Derek, you mentioned that the American administration is going to be spectrum very soon. Chris Hadfield mentioned yesterday the Canadian government's looking into doing that. And Yesterday, there was a few times I heard that there was concerns that the bigger operators would just gobble up that spectrum and hoard it. You can't talk about telecom and the expansion of telecommunications without hearing digital sovereignty and national security issues now. And I'm wondering from a regulator's point of view, what conditions are being considered to ensure that when that spectrum is released and then controlled by whichever operators control that spectrum, which conditions based on the concerns of national security and data sovereignty are being considered and could be implemented realistically? Thank you.
Okay, would any of our regulators like to come in on that?
I think I'll try, but I will give a pretty big caveat that, in the United States, the FCC is responsible for the licensing. So, I don't know, I have a lot to say there in terms of license conditions. I mean, I think you make a pretty good point. I'm trying to think of what you really mean by national sovereignty there and data, but I'm not sure I have a really great answer other than I think, national security considerations are always part of it, right? There are conditions on licenses. If you have, foreign ownership, of course, you're gonna have some requirements there working through the national security community. FCC does have some, conditions they put on licenses, but I'm, probably be going out on my skis to say much more.
Perfect. Well, unfortunately, we're out of time in the session. I think there's lots more we could discuss, but we'll finish there. And I'd just like to thank all of the panelists for their time and all of you for kind of getting involved in the questions from the room. So thank you.
Thank you.
Yes, thank you very much to our panelists. Ken, thank you for joining us virtually from Hong Kong as well. Really is appreciated. Thank you. And thanks to Cameron for moderating that session too. So we now are, it's time for our final refreshment break. So refreshments once again being served in the area just out to the left, or to your right, sorry. Please do make sure we have the 2 demos running there. So please do check out the 2 demos from ThinkRF and Roeder and Schwarz. If you haven't done yet, those are available out in the refreshment area. So make sure you go and check those out. And then we are back here, if we can be back here at 10:55. So in 25 minutes, and we'll have our final session looking at reimagining connectivity for 6G. Thank you, everyone. Thanks, everyone at home as well. And we'll see you back here shortly.
Sorry, that was not an error.
But I'm not so happy with if you are connected with This gets to a very fundamental question. Just go so far on, and then you get to the best how you felt that is. Yes, I'm going there's golden spectrum where it's not really efficiently used. That's what I see. So all the information where does not pay the right thing, and this is how important it is. Because it's still not created. Let's do it. It's my
Just because of these things, we have to get some money out of it. But together, what we are doing is also the auction in 2019. We didn't buy especially
Right? And the good news for you is that what you are, right? Like, I think you're going to should be doing the same context, right?
There are people in
It's good. We'll pick it up. That's a good thing. We're supposed to see that. I'll pick it up. No, but I think part of the challenge is how we have this. But every time I because it was the border, we do it very easy. It's tough. You're wondering because we lost if there was more flexibility. Like if Europe would let the Irish sort of, on these sorts of things, you could. And I get why that's politically unhelpful.
So, am I on? I am on. Hello, welcome back, everybody. So if I could ask everyone to retake your seats, if possible, and if I could ask our panelists for this final session, who I think are all here, pretty much, apart from Parvez, possibly, to come and join us. Parvez over there as well. So if I can ask you all to come and join us on stage, and we'll get started in a second. Thank you. So, mic's on. With the order, maybe we go David there, Chantal next.
Sorry, do you want me back over this way?
No, I'll go the other way, that's fine. And then Jan, if you go here, okay, and Bill can go here. Perfect, thank you. We'll have this for you as well.
Yeah.
So then this is the questions from online. So these ones from the last session. But yeah, they'll go up there as well. So. Okay, so I'll introduce you quickly. Sure. The online people as well. Okay, aye. So welcome back, everyone. Great to have you all back here, and hopefully everyone online is now back with us as well. And we're here for the final session of this year's summit. So it's flown by, but really happy to have this final session now to maybe build on the discussions that we've had yesterday, but particularly from this morning. So first of all, this morning we talked in the earlier session, we talked about 6G roadmaps, looking at some of the key bands. We wanted to keep that discussion around connectivity, around spectrum, but looking maybe at how connectivity and how connectivity is provided and used, and maybe the the relationship between different providers, how that's all going to change as we move towards 6G. So this session is called Reimagining Connectivity for the 6G Era. And as I said, technology, systems, and the shape of the longer term ecosystem. So again, really looking forward to this session. And we have a fantastic and an international lineup of speakers once again here to talk about these issues. And very happy to have with us as well Fahadl Parvez from APT, who's going to be moderating the session. So Parvez, thank you. I know you spoke yesterday as well, so we're working you hard, but great to have you back here, and I'll pass over to you.
Thanks, Dan. Good morning to you all. This is the final session of this 6G summit this year. So I think since the final session, we have a lot of time to discuss, and then the important issue for discuss. And then, as Dan already mentioned, we have very good international panel today. Two from the regulators and also two from industry. So mobile industry as well as the industry, Cisco with us. And also, so the session title today is Reimagining the Connectivity for 6G Era, Technology, System, and the Shape of the Longer Term Ecosystem. When we discussed yesterday regarding the 6G connectivity ecosystem. As we understand that in the 6G, we are moving beyond the traditional mobile network. We will have the redefining the mobile network beyond boundaries. There will be the integration of terrestrial and NTN. We do have a combination of licensed and unlicensed system, and then diverse provider. Not only the performance, but also we heard yesterday that there will be shifting policy priorities for 6G. Beyond performance, there will be some human-centric aspect that will be included in 6G. The sustainability, resilience, and digital inclusion. So the performance, as well as this shifting policy priorities, human-centric policy priorities for 6G. So looking at those aspects, both the aspects, operational and the policy priorities, then we need to talk about the spectrum. In this session, basically, we are going to examine how spectrum policy and the regulatory framework may need to evolve to support this more complex and dynamic future. This morning, we heard some of the spectrum roadmap-related issues. And here, actually, we will try to reimagine how the spectrum allocation and assignment will be done for the 6G era. So as usual, our panelists will give a short introductory remark. Each of them will have 5 minutes for the introductory remark. First of all, I would like to invite David. David is the Group Director of Spectrum of Ofcom. David, please.
Okay, did we get slides for me, or am I doing this slideless? So really quick, I thought I'd start, if we went to the next slide, with a really quick update on the types of work that I get to do my own. Okay. Of sort of the diversity of spectrum-related work that you see ending up happening over time. Terrestrially, stuff for public mobile networks and for private and local networks, whole mix of different bands. We've had a ton of stuff emerge on drones, both drone detection and drone control. We recently have done a review on events for program making and special events. And if you look at the technology shifts that are happening there, and the demands on those types of events increasing, their demand for spectrum is going up about 10 to 15% a year in the region, in the areas that they need it. And although they've got new tech that helps, it doesn't solve for everything. We have demands for critical network infrastructure. Net zero objectives mean that you need a network that allows for cold restart across a very distributed network out to the edge so that you synchronize everything. That lays out a comms network that's very different than it is before. So, 6G has the potential to serve a number of these needs, but I think each of these sort of verticals or segments is looking for their own stuff. And obviously on the satellite side, it's been it's somewhat hectic time, I'd say. And you'll see things like QV, WD, E-band, right? How many it used to be just IMT bands that proliferated all over the place, but now it's satellite as well. So that's all the stuff we're doing. And obviously we're looking, if you look at the more purplish stuff, the emerging 6G band, 600 megahertz, we've recently completed some work on upper 6 and D2D. And I'm going to talk a little bit about both of those a bit more. So, because they probably relate most to where we're headed for 6G. So on upper 6 gigahertz, we recently did a statement consultation framework in place by end of year to enable shared use of the upper 6 gig band between mobile and Wi-Fi. And even though we say shared use, it follows what Europe has called as a prioritized band split, with priority for Wi-Fi in the bottom 160 and priority for commercial mobile when it deploys in the top 540. The early access is going to be done in a controlled mechanism through automated frequency controllers to help with future clearing and awareness of where the stuff is. There's certainty to deal with sort of predictable demand for the Wi-Fi industry between 6425 and 6585, but also certainty for the commercial mobile industry that there's going to be spectrum there for 6G when they need it. Part of it is people ask, well, why are you going now? Why, aren't you worried about European alignment? We're still hopeful for good alignment. We think the 125 megahertz that's above would lead to close alignment with the RSPG. But at the same time, if we want spectrum to be ready, we have incumbents in the upper 6 that take us 5 years to clear. If we want to be ready for 2030, well, it's already too late for 2030. We're already looking at 2031 for that. So when people ask me, well, why aren't you waiting? That's part of the reason, right? Is if you want to be ready in a timely fashion, some of this means moving early and, continue to work with Europe and the CPT to make sure we have harmonized technical conditions that support deployment. D2D, by being an island, as somebody mentioned to me, we got to go a bit earlier than many of the other parts of Europe. But we're on, it's first steps towards more integrated NTN framework, very similar to what you've seen in other parts of the world. But we've also had to carefully manage expectations with the nations inside the UK and with politicians and with people looking at the service that it doesn't solve all of the problems, right? Good solution for coverage, in areas that are less populated, you'll get, quite some good increments to come in service capability, but it isn't going to cover everybody the way mobile networks do today. You still need a mobile networks investment. And if I go on, well, I still got time. A whole raft of stuff for spectrum for 6G. But if we look at it, obviously, there's some 3G, 4G, 5G refarming that would be priorities for us. We've committed to doing a review of upper C-band in 2028 to look at how the private networks demand and that band is there. We have a DTT transition that's become a very active conversation with government. Our licenses expire in 2034. Upper 6, which we've talked about, a whole bunch of other WRC bands. I think since I'm timing out, I'm going to leave the challenges and opportunities for the discussions, but I think there's a couple of things I'd emphasize in there. There's incumbents in all these bands. Moving them is getting harder and harder. It does mean thinking of sharing. Investment, we're asked to maximize the use and efficiency of spectrum. When there's investment uncertainty, that makes it hard to provide regulatory uncertainty. And the last one I'll mention is handset and device transitions. One thing to think about is if we hark back to the radio world, eventually you hit a point where it became tough to introduce new gen technologies because your device population doesn't turn over fast enough. And I think there's something to think about as handsets become more expensive, harder to integrate new things in, people change them. How do you get to the point where that investment case works? And I think there's something to think about as we go to 6G or next generations about how do we smooth those transitions. But I'll pause there, being over.
Thank you, David. So David focused on the UK's policy for the 6G spectrum bands, especially 6 gigahertz, as well as the challenges and opportunities for the regulator. So now I would like to invite Chantal Davies, Senior Director of Regulatory Policy, Innovation, Science and Economic Development of Canada, for your remarks.
Thank you very much, and welcome everybody to Canada. I only have one slide. I wanted to speak more about what we've been doing to prepare us from a regulatory point of view at looking forward to 6G, but also for 5G. And I think they all evolve together. So you saw this, this graphic from Chris on the first day. We have made a lot of spectrum available for 5G, but in Canada, you can use these bands continually for whatever the next evolution of spectrum is. And the way that we manage it is when there are new technology changes that we need to make to those bands, we do that and allow our operators to move forward on this. Those bands include also our non-competitive local licensing bands. So just so you're aware that we're looking at those also as future 6G bands. So I just wanted to talk a little bit from a regulator point of view of the things that we've been putting in place that I think will help 6G, but also that we need to consider as we go forward. So more and more we're making flexible use available. So all our auction bands are for flexible use. You can use it for mobile, fixed, or fixed wireless access. This allows people to do fixed wireless access in rural areas as well as doing commercial mobile in cities. But also, you heard about our satellite processes that we've finished and going on. So our supplemental mobile coverage by satellite is available now, and we're doing the MSS consultation. The idea is then also some flexible use for commercial mobile bands that but with some rules around them compared to what is available. We also have a consultation on the street right now about drones using commercial mobile bands, so allowing a lot of spectrum use in those bands. Spectrum where it's needed. You saw the map on the first day from Chris. There's a lot of areas of Canada that are very hard to reach. We heard from the last panel that we need clear spectrum. Well, I have questions around what clear spectrum means and where it needs to be cleared. So it's very hard to make an argument to clear out a public safety agency from using their fixed point-to-point in 7 to 8 gigahertz for technology that may never make it there or will make it there in 20 years, and clearing them out now. So timing is going to be really important as we go forward. And I do see that we'll do more things like we did with 3800, where we allowed some of the satellite operators to stay in order to continue to provide services to rural areas. Having the right licensing processes, and that sort of mixes with the mix of spectrum for different use cases. So what kind of processes do we need? One of the things we talked about, we focused on is our non-competitive local licensing. That is in some ways a test case to have an area-based licensing that we can make available for those areas where it's needed. So when you need local spectrum in those areas, you can get access to it. And also to have spectrum available long-term. It's not just a one and done like an auction. So there are some places in the country, especially in Canada being so big, allowing that that kind of licensing to be available when a mine needs it or some other private network needs it, but also for our operators. We did not keep our operators out of those bands. They can use that as capacity long term. We heard this morning about spectrum roadmaps. This is something that Canada is working on. Obviously, we're reaching the end of our 2027 roadmap. I'd like to say we checkmarked most of the things that we said we were going to do. But going forward, what is that roadmap and what's the timing for all that spectrum? As David said, clearing people out is difficult. It takes a long time. We do like to set those roadmaps far ahead. So we will be looking soon, and that's something we would consult on to find the priorities for our operators. And so, we were talking about long-term for the session, the things that I would hope as a regulator to see in some of from the operators and as the technology evolves is maximizing the use of the existing spectrum. A lot of our spectrum that we put out already was maybe put out when 5 megahertz was good enough, and there was mix of things there. So what can we do to maximize that existing spectrum? Coexistence with other services is going to continue to be important. As we mentioned, we're looking at where do we clear and where do we not? And then also sharing with like services, when we were looking at something like non-competitive local licensing, it also would need to share with the other operators. So how do we make that happen going forward? Thank you.
Perfectly on time. So she focused basically on the regulator's role and approach for managing the spectrum for mobile communications. May I now request Jan Hendrik for your introductory remark. Jan Hendrik is a Vice President of the Spectrum Policy and Project Deutsche Telekom.
Yeah, thank you. And good morning, and thank you for the invitation here. Pleasure to join the discussion here in Ottawa. When we speak about 6G today, I think we are at a relatively early stage still, but this is exactly why the current discussions are really important. Deutsche Telekom's perspective is that 6G is not just to be understood simply as the next radio generation or as a pure capacity upgrade. It's more. The bigger question is how connectivity systems evolve in an increasingly AI-driven and software-defined and highly connected world. That evolution raises not only technology questions, but also important policy questions around spectrum strategy, resilience, interoperability, sustainability, and also global coordination. With that in mind, let me briefly show how we currently see the evolution of 6G. So when we look back from 2 to 5G, each generation enabled a fundamentally new capability like voice, mobile, internet, broadband, IoT. And for us, 6G is different again, but not just because of more G. The real evolution is from connectivity networks towards intelligent and AI native systems. The value of 6G will come from the integration of connectivity, distributed compute, sensing, automation, and AI-driven orchestration. Many future capabilities are therefore system-level capabilities, not only radio interface innovations. Of course, the technologies will continue to evolve. New spectrum bands, improved efficiency, support for sensing, and more flexible solutions, but operators will only support major technology transitions if they deliver measurable improvements. I think we heard that already in the performance, in operational simplicity, energy efficiency, or customer experience. So from our perspective, 6G must build on a real industry and societal needs, not technology push alone. And really important from our perspective, 6G should become an AI native platform. We heard it already, focus on automation, personalization, resilience. So it should not only be an add-on feature layered onto the networks afterwards, it should become part of the network. AI is part of the network architecture itself in 6G. The objective is a highly automated and customer-centric network operation. Future networks must increasingly understand intent rather than only transport data packages. This means networks that dynamically adapt to user context, application requirements, device capabilities, and energy conditions. We also see strong potential in sensing. We heard that also several times in the last days. That's probably the most spoken word here. So they may support positioning, environmental awareness, industrial automation, physical AI applications. This also means a stronger convergence between connectivity and the distributed compute infrastructure. And not to forget, from our perspective, a major requirement is trust. So 6G must be designed with resilience and quantum-safe security principles from the beginning. Especially the current geopolitical environment, secure and resilient infrastructure is becoming a strategic policy issue and not only a technology issue. Coming to spectrum, from a European operator's perspective, the first principle for 6G from our perspective is that all existing mobile spectrum assets will remain the foundation of the 6G system. So we are talking about more capacity. We are not talking about 6G spectrum. We are talking about capacity and spectrum to enable the needs. The transition from 5G Advanced towards 6G needs to be evolutionary wherever possible, and we expect all currently assigned mobile spectrum bands to continue playing an important role. On top of that, the upper 6 gigahertz is the most relevant resource, a new band for mobile capacity expansion. We have heard that several times, and I can't just underline that. Without it, we will not be able to provide the connectivity needs of our customers. It's the only band and the only realistic option to come to wider bandwidth and higher capacity demands. And by the way, 80% of the world's population, so countries representing 80% of the world's population, are now supporting this band for 6G. Another important option, the 700 mega, with this 700, no, sorry, mixed up. And what we see in Europe was a mix of the 6 gigahertz band for mobile and Wi-Fi from an integrated operator perspective is a perfect fit to solve the needs of the people at home and underway. Especially other spectrum is needed. We are with 6 again, 6G, 6 gigahertz, 600 megahertz. So this is the other band we are looking to with high importance in Europe. So getting, let's say, a capacity level, layer for 6G. For other bands, what we have seen, we see at the moment not so many chances. So from a European perspective, and if I see the discussion in CEPT, 4 gigahertz will not play a role in Europe, I fear. And also in the 7 to 8 gigahertz range, we are just talking about 7125 to 7250 in Europe. All the rest seems to be out of scope for me. More promising would be the upper C-band. Europe looks at harmonizing that at the moment just for local use. But the 38242, we should think about if that couldn't be accessed also with high power for area-wide networks and not only for local networks. I don't see an efficient use of spectrum here. We have had several set-asides in Europe that are not really used for that. On the North American perspective, the debate is a little bit different. We have also the subsidy, our daughter company here in the US. So there we don't talk about the big chunk of spectrum like the 6 gigahertz, but more fragmented. But Derek, I think, outlined there's a lot going on at the moment with 2.7, with 4 gigahertz, in the 7 to 8 gigahertz range. So very important to move on here as well. So other options, not really globally the same, but also this is going on and it's important to get this. So being over time, I just skipped the last one, just saying we have a lot of research activities. We bundled our forces between on both sides of the Atlantic with research hubs to develop 6G in a way that this can be a globally aligned standard in the future and for the benefit of all of us. 6G is strategically important. Success will not be defined only by new radio interfaces. Success will depend on whether we can create deployable, interoperable, energy-efficient, secure, and AI-native systems that provide tangible benefits for society and industry. Thank you.
Thank you, John. Now we would like to invite Bill Davenport, Senior Director, Spectrum and Technology Policy, Government Affairs, Cisco.
Thank you very much. Appreciate it. excuse me. Speaking last on the last day of a conference is kind of like rain on your wedding day. It can be nothing but good luck, hopefully. My name is Bill Davenport. I am a Senior Director for Connectivity and Technology Policy at Cisco. It's a real privilege to be representing Cisco here in Ottawa. Cisco has been a proud member of the Canadian business community since the 1990s. We have 3,000 employees here in Canada. And so it's a real honor to be here talking about 6G with you all. So I want to talk about Cisco's vision of 6G and our thoughts about how that relates to our connectivity goals and all the goals of everyone here. As we look towards 2030, we aren't talking just about a faster version of 5G. As others have talked about at this panel and earlier over the last couple of days, we're at an inflection point. At Cisco, we view 6G not merely as a connectivity standard, but as the foundational harbor for the next era of human and machine interaction. So I want to share 3 pillars of how we see this evolution unfolding. Can we have the next slide, please? So point number 1 is our 6G vision, AI for wireless, wireless for AI. AI for wireless means that we're embedding AI directly into the network stack, from the radio layer to the core. We're building networks that can sense, learn, and optimize themselves in real time. It's essential to do this because our research shows that network operations are becoming exponentially more complicated. And as we'll discuss later on, AI is already educating us about how our networks are vulnerable and will help us make those networks more secure. The second component of our strategy is really honestly even more important, which is wireless for AI. We're turning the mobile network into a distributed AI engine. By integrating accelerated computing, like our work with partners like NVIDIA and AT&T, we're bringing inference closer to where the data is actually generated, the network edge. We're shifting from a world where we backhaul everything to the core to a world where the network itself acts as a supply chain hub for AI services. For Cisco, this is about enabling physical AI, where digital intelligence is embodied in the machines and the sensors that interact with our physical world. And we've talked about some of the examples over the last couple of days, drones, autonomous vehicles, robots, just everything is going to be connected. And this is like the era where we're going to be incorporating AI into all those IoT type operations. Point number 2, and I think it's really important to drive this home, and others have mentioned this as well, is we can't let the race for 6G outrun the customer. If 4G was the era of video and 5G was the era of connected apps, 6G is going to be the era of AI native networks for connectivity. But we need to make sure that there's a business case at the end of the rainbow, candidly. The lesson that we learned from 5G is that infrastructure deployment must be matched by clear, scalable use cases. The 6G business case isn't just about throughput, it's about tokenomics. Bits are now turning into tokens, and tokens are turning into revenue. But to capture this revenue, we must avoid the reactive trap. Cisco released a State of Wireless report a couple months ago where we talked about what we call the wireless AI paradox. And that means that AI is the leading driver on return on investment for telecom providers among many others. But it's also the leading source of complexity. It's the leading source of cybersecurity challenges. And what we're trying to do when we talk about the paradox is that we want to make sure that our service provider customers and other network operators aren't so overwhelmed by the complexity of their networks and the cybersecurity challenges that AI presents that they aren't able to take advantage of the strategic opportunity that AI actually brings to make their networks more secure and to operate more sustainably and more efficiently. One other thing I should mention, as I referred to earlier, is that 6G may not be necessarily for all end users as quickly as possible. We have to move in a methodical, deliberate way because 6G additionally has to be driven by enterprises. Ultimately, you need a customer to drive the revenue that actually supports the capital investment that service providers are being asked to make for 6G. We want to work with our service provider customers, provide software-driven solutions that allow for network upgrades in a reasonable time frame, prioritizing deployments where there's a strong business case. We want to work to make sure the business case actually justifies the deployments and not do the deployments and wait for the business to come. My final point is the role of complementary technologies like unlicensed. There's been some references to unlicensed in the context of the 6 gigahertz band, and I think it's important to really drive home that 6G will not succeed without a strong unlicensed technology presence behind it. You need to have a hybrid ecosystem where licensed and unlicensed technologies work together. Unlicensed spectrum, specifically the 6 gigahertz band, is a strategic growth engine. Wi-Fi 7 and Wi-Fi 8 are being built to provide the same level of resilience and determinism that exists with 5G technology today. In high-density environments like hospitals, stadiums, manufacturing hubs, Wi-Fi is the primary connectivity layer. Cisco's perspective is clear. Spectrum policy should not be a zero-sum game. To deliver the multiplier effect of wireless, we need regulations that provide not only spectrum for mobile services, but also adequate spectrum for unlicensed. That's what's going to allow the high-performance, low-latency applications to flourish. If we limit unlicensed access, then we limit the potential of the entire 6G ecosystem. Finally, in closing, the transition to 6G needs to be a collaborative effort. It requires policy agility, a security-first mindset, and a willingness to embrace new sharing models like AFC, the Automated Frequency Coordination System that David referenced earlier. Cisco is committed to working with our partners here in Canada and globally to ensure that this next generation of connectivity is not just faster, but more intelligent, more secure, and more inclusive. Thank you, and I look forward to our discussion.
Thanks, Bill, for focusing the importance of the complementary unlicensed technology for 6G. So now we do have sufficient time for panel discussion. Actually, yesterday and this morning, we discussed a lot about the capabilities and the technologies of 6G. But in order to enable 6G, this is important to have proper spectrum allocation and licensing mechanism for 6G. That is the root of the success of 6G. So those points, actually, the allocation and the licensing mechanism for future, that will be our discussion point now. And we do have listened already to our panelists. Now, I'd like to start the discussion. If you are interested, you can raise your hand for the questions, or those who are attending online, you can post your questions in the forum. So let me start my question. Especially, I'll try to focus the discussion on two different aspects, the allocation aspect and the assignment and the licensing aspects. First of all, when we talk about the global alignment and global interoperability, it is important how we are allocating spectrum for mobile services and how do we identify for IMT. There is a thinking, I guess we understood from some WRC results that sometimes people say, oh, there is allocation on mobiles, and then whether we need the approach of identification for IMT or not. And then also, sometimes, someone even don't care about what is allocated or not, but start the thinking about the services. So now I would like to ask our panelists, like, how do you think that the current spectrum allocation approach is sufficient, or we need to look into a new kind of thinking for the spectrum allocation and identification for IMT services or the 6G? Yep. Bill.
I think the current process has probably served us fairly well till now. I think it's allowed for harmonization and the economies of scale that have been beneficial. I think at times, though, you see the more bands we allocate, the less maybe the harmonization helps, because it allows people to pick and choose, right? So for harmonization to be effective, I think it also has to be focused. And I think because a lot of the easy pickings maybe have been gotten at now, and that makes that harmonization more difficult. And I think as you look forward, it's regulators get asked to make efficient use and make sure it's delivering value for citizens. And that's tougher to call. And when you start looking at big channels that you're allocating, that's big chunks of spectrum you're taking away and big chunks you're putting on other stuff. So I'm not sure how to do it, but something that balances regulatory certainty that allows people to invest, but also gives flexibility for making changes as things change, would sort of be a bit of a panacea, but I'm not quite sure how we get there yet.
Sure. I could put my hat on from when I used to go to the ITU meetings. We, as Canada, we are a small market. Obviously, we need to see global harmonization. We're not going to see equipment built for Canada. So we do follow all of the work at the ITU, and we do participate. For us, it's great to have the options. I'm going to be a little bit more different than David and say having those options has given us a good opportunity to pick and choose in some ways. That I don't think there's another mechanism that I can see making it happen. We do follow what's going on internationally, but also when we do see there's a groundswell happening on bands, we start preparing. So for example, if you look at the 3 gigahertz bands, early on, it was not as harmonized, but it did find its way there. We started work on that as soon as we could because it does take a long time to clear spectrum. I can't say that there's a magic way of doing it though going forward.
Yeah, so we heard from the regulators that current allocation mechanism at this moment is sufficient for thinking 6G era as well, correct? So let us listen from the industry.
Yeah, then I try to continue. Thank you. What we see is of course that the discussions are heating up. I think somebody used the word fight this morning for the 6 gigahertz band, and this is very much commercial, but maybe also true. And the reason for that is that everybody needs more spectrum, and it gets complicated to find it. Yeah. What I see is we have new options. So 10 years before, probably nobody would have thought that we can deploy 6 gigahertz on a macro network. So we get more options. But anyway, this might come to an end. And if there is more demand for connectivity, we will really need to think about how to please the demand that is existing. The current processes are, let's say, from an operator perspective, sometimes really slow. If you go through CEPT discussions and everything, it takes a lot of time. Sometimes you wonder why these decisions come like they are. We would see in some areas a benefit of having really demand-driven discussions, so making really an cost-benefit analysis before you assign spectrum to certain bands. An example is this 400 megahertz for local licenses. Is this really needed? 400 megahertz. Nobody did a study. Nobody did somehow evaluate how much spectrum is needed there. Is it efficiently used? Will that be efficiently used? So these kinds of questions need to come into focus in a world where the spectrum is getting more and more scarce, and we need to find ways to somehow get maybe even better in allocating the right spectrum for the right service.
Yeah, I understood that the concern of the industry for a long time, I guess. So maybe Bill.
Yeah, it's an interesting question. Before I joined Cisco, I was at the FCC for about 20 years and thinking about these issues. And I appreciate what Jan is saying about the speed issue. The CEPT in particular, the number of, I think we may disagree about the specifics of the 6 gigahertz band, but I think there's no less than like 5 or 6 working groups right now studying different technical aspects of implementation of the RSPG recommendation and coexistence between unlicensed and licensed. It's daunting and frustrating sometimes, but I feel like the technical work that's involved with those committees is really critical. I just wish that it would take place earlier and more rapidly because technology isn't waiting. That's the reality is that, people are implementing technology. We're developing, our own equipment, our own software, and we're stuck waiting for the regulator to catch up because we don't want to do anything that might get crosswise or become redundant or unnecessary down the line. One thing I will say that it's not so much a process issue, but something more holistic, which is it would be great to see customers more involved in spectrum decisions. One of the things that we find ourselves doing as Cisco is really carrying the water for our end user customers, enterprise customers in particular, because they don't really have a voice. They don't have the resources to be engaged in the spectrum policymaking activities at the ITU or in the various regional bodies. So that's something that I would, this is, I guess, just my wish list, but I would love to see enterprise customers more engaged in the process.
So anyone would like to have any questions? Yeah, the back. Introduce yourself. Yeah, from Costa Rica, I guess, correct? Microphone, please.
Thank you. Hi. Thanks for the panel. Good presentations. Considering the conversation that you are having, I wanted to ask a question related to the situation. What I see here is that we're talking about getting carriers of 400 megahertz and considering also the upper 6 gigahertz band, where if you take that into account, you will take the few 160 megahertz channels that could be used in Wi-Fi. But the main question is, considering that, and the regulator has now to find an option to clear another bands to have these new allocations. Do you think that we will have to wait till 7G to have a dynamic spectrum integrated in the design of the technology? Because it is real. We have been talking about this is not a run. We're not running here, but at least if you see it by the perspective of at the beginning for 5G, let's clear 100 megahertz per carrier, and now 400 megahertz per carrier. It just seems like a run, and also I think that there are CBRS solution, AFC solutions. I don't know why 6G is not thinking on having a spectrum sharing by design.
Yeah, thanks. Actually, I was going to ask the similar type of question. I was thinking in mind, we are talking about global alignment and global interoperability, but we do have the reality in front of us, as you mentioned correctly, on the 6 gigahertz, which is the pioneer band for, going to be the pioneer band for 6G. And then, as you mentioned, that the per carrier requirement is 400 megahertz. Now, if you consider a country with dense population, and then if we are not harmonized in upper 6 gigahertz band, then how we can provide that much of a channel for multiple operator? Where is the frequency, from where it will come?
You're looking at me?
Any of you, please. Regulator, please, yeah.
So we have not decided where that would be and where we would make it available. We have followed the US with 6 gigahertz and made that available for Wi-Fi because we think that's very important as well. Where is that going to come from? Honestly, I don't know at this point because for us, it depends on where the harmonization comes into play. If 7 to 8 gigahertz becomes a harmonized band, that's something we would look at. We are looking at all the bands that the US is putting out as well. I don't know where it's going to come from. That's my somewhat bad answer. Thanks.
You do like touch?
Yeah, I guess I think it's tough. I think there isn't, if you follow it to the ultimate conclusion, you're looking at 4 times 400, and there isn't really 1.6 gigahertz sitting there ready to be sort of idle enough. And I think, and somebody mentioned sharing and dynamic. I think there's other forms of sharing rather than dynamic. I think what we see is where the areas where there really is the demand, everybody wants it. In the other areas, it's sort of available. And so there's maybe a better thing we can do about making it available where it's not being used. But dynamic access to solve the peak demand is probably not necessarily the way to do it. And I think what we tried to do through some of the discussions on Upper 6 in Europe was to try and say, look, we've got to find ways to do lower power. And I know that that has trade-offs on network density, but lower power allows you to do more reuse. Or in our shared access bands, we've looked at assuming that people will collaborate better. So we assumed synchronization, and that multiplied our spectrum supply by a factor of 10, right? So even though spectrum is finite and scarce, there's things like lowering power, better antennas, better receivers, a whole sets of things that requires collaboration and a mindset that says, I'm not going to get clean spectrum. How do we make better use of those techniques? And that requires us all sort of to work together. And I think that's part of it.
Any industry, do you like to touch this?
Yeah, I mean, the question, where do we get 400 megahertz from is really good, and that's what I said, the spectrum is scarce. So we are happy with the 6 gigahertz band to have maybe 200 megahertz per operator to be operated, to get an efficient way to provide the capacity that we will need for the networks. I mean, we talked about all the 6G new use cases. If you get AI, the networks, XR and everything, they might really push the capacity needs. We see already today restrictions. We have rolled out all our spectrum. For example, in Germany, everything is deployed, and we see already C-band cells completely overloaded. So that's why we need the spectrum. And so as soon as it's there, we will bring it into use. And that is probably after CEPD has finalized, and then the awarding procedures are through maybe by 2030. And that's not why we want to be so late, but we will not have a chance to do it before because we will not have the license before. So that's where we need to go. And afterwards, let's see. I don't see where 400 megahertz of spectrum are available except in very high bands. These are not feasible for macro deployment. We see the millimeter waves probably coming in the next decade into play. That's the next resource maybe to be used. Of course, everybody said you wanted it for 5G. It took a little bit longer, but it will come from my understanding. And there you could have 400 megahertz channels. So let's see to that. That might be the next option I could see here.
But I think the 400 megahertz channel requirements in the mid band, probably, correct? Not in the millimeter wave band.
Yeah, and I should maybe have been clear because as you just said, there's 5.4 gigahertz sitting there ready to go in the millimeter wave in many markets, including the UK.
No, I mean, far be it from Cisco to question our service providers' need for 400 megahertz of spectrum. That's their decision, that's their view, and we defer to that. I think that from our perspective, we think that artificial intelligence tools that we're developing right now actually could be really very useful in terms of making sure that spectrum is used more efficiently. We just did a demo last year with NVIDIA and T-Mobile and some other companies where we were demonstrating how artificial intelligence tools could be used in the enterprise context, to be fair, for spectrum management purposes, and how to make sure that the spectrum that is available is managed as well as possible. Certainly, from the US perspective, we have every confidence that our American service providers will be able to compete and win in 6G with the spectrum that is available now and will be available under the President Trump's One Big Beautiful Bill Act.
Yeah, thanks. I think since WRC 2007, we have seen that the spectrum has been identified or allocated in a fragmented way, correct? So this band here, and then in other region in different bands. So how do you feel like, which is more important, like to have like a fragmented bands or like focus on certain bandwidth for the necessity of the future communication technologies? Any of you?
Yeah, maybe I start. And so from an operator perspective, of course, contiguous spectrum has a big advantage in terms of rolling out. So finding very fragmented last pieces of spectrum here and there, you always need to divide it by 3 or 4 if you give it into the market. So usually if you find some, like let's say 100 megahertz somewhere in the 15 gigahertz band now, then there's 20 to 30 megahertz per operator. Depends if you have 3 or 4 operators.
Yeah.
So with that, in this areas, you can't do a lot, and you can't roll it out in an economic, feasible way. So that's a problem we see at WRC 27. From an EU perspective, at least, there is, besides the 7125 to 7250, what is adjacent to the 6 gigahertz band, no spectrum that has a sufficient bandwidth that seems to be an option for further spectrum. So from my understanding, it is important to have it contiguous. Smaller parts of spectrum is good for coverage in low bands. So there, let's say this is the 600 megahertz band would really help. But in the higher areas, we need contiguous wide bandwidth.
Would you like to address?
Yeah, I think we have not regular, but reasonably frequent discussions on defragmentation of bands with our service providers, and the pragmatics always get you. Somebody has to deploy new equipment because it's not tunable across the range that you're trying to defragment. Some of the conditions in part of the band are more restrictive, and people feel that they don't want to give up. So I think everybody recognizes the benefits, but the pragmatics get challenging. I think we are talking, given the benefits and to efficiency overall, at looking at how we license spectrum bands going forward, and whether requiring, that you would be licensed to use somewhere in the band, right? But that encouraging equipment that tuned across a fairly broad band so that you could defragment, like in 3.4 to 3.8. And if you add 3.8 to 4.0, could you repack everybody when you do that easily, rather than running into debates? But there are real technical and commercial challenges in getting that to work.
Chantal, do you have any?
Yeah, so when it comes, I would talk about defragmenting bands as well. So we've started a process to try and change one of our bands, the 2500 megahertz band, because we had gone with a paired band, and we want to move to potentially move to a TDD band. It's difficult. We just got comments in from our operators. We've been talking to them closely. It's about timing of equipment. It's about timing of when they're planning to deploy equipment and their investment certainty and investment. And so that's going to take a long time. But I see that what we're doing in 2500 might be a possibility to look at other bands. So for example, we have our PCS and AWS bands. They were designed when we wanted 10, 20 megahertz blocks, and contiguity is becoming more important. From a perspective of what we put out, we do at these days have been very careful to make sure that we are optimizing for contiguity. So if you look at our auctions, that's one of the optimization pieces that we put forward. So I think it's going to be a mixture of going forward, optimizing for contiguity, and looking at some of those bands that we already exist and making them better.
Thanks, Jonathan. Any comments or question for the 6G spectrum allocation side? Yeah, please.
So today we talked a lot about AI native 6G, autonomous network and dynamic spectrum coordination, distributed edge intelligence. So, but if future wireless system become too complex for human to fully understand in real time, how do we prevent the industry from creating critical infrastructure that operators can no longer truly explain, validate, or control? So the question is really about the long-term consequences of making the wireless network increasingly autonomous and AI-driven. Traditionally, telecom networks are highly deterministic system. Engineers can usually trace the problem and reproduce failures, validates behaviors, and understand why the network makes the certain decisions.
Yeah, make your question in a shorter way so that they can understand easier.
Okay. So how do we maintain a trust, accountability, validation, and human controlled over systems that are increasingly autonomous? So how do we balancing the AI autonomous with the carrier grade reliability and explainability? And
your question? Okay.
Thank you.
So basically, we are trying to discuss about the spectrum allocation and licensing procedure here, but
no, it's a great question. I think it's a very fair question. It's one of the things that Cisco is very focused on is we want network operators, whether they're service providers or enterprises or what have you, to embrace artificial intelligence, because we believe that AI is going to ultimately make our networks more secure, more effective, more sustainable. But at the same time, there is this issue of once AI, the only way to really get the full benefit of AI is to use autonomous agents, where you have one agent talking to the other and the human element is not directly in the middle making those decisions on a piecemeal basis, because you really need to make these decisions at scale and with massive scope across the entire network. The reality is that bad guys are using artificial intelligence to probe and attack our networks, whether they're service providers or otherwise. Human beings are not going to be able to compete with that. So you have to use artificial intelligence agents to be able to work with that. You have networks that we're talking about incredibly complicated dynamic spectrum sharing across many, many different countries and many different situations at different times, different sort of conditions. So we need to embrace the age of agentic AI. So getting to your question, what we have to do is work to establish guardrails so that the agents actually know where to go and where not to go. We need to have very strong, robust cybersecurity for our AI agents so that they aren't easily tampered with, and so they can't break those guardrails. And we need to understand the technology. I don't want artificial intelligence to become a magic type environment. We want people who are capable of understanding it, but we don't want the human element to be in the middle of all those decisions because they simply can't keep up.
Yeah, thanks. Next, maybe we discussed about the allocation issue, but another important aspect, because allocation is there, but the licensing process, assignment and the licensing process is very much important. If you look at the different parts of the world, or in Asia Pacific, or even in African or South American, many countries actually did not start at 5G service because they could not decide the licensing price of the spectrum. So that is becoming more important in future, like how do you go for the licensing mechanism, and then what will be the price? So my question, like whether the current licensing practice and the way of finding spectrum price is okay, or we need to go for a different approach for 6G, because we have seen that in very many cases that because of the licensing, high price spectrum are not sold, and then the people cannot get the proper benefit from the technology. So how that can be addressed in 6G so that the big chunk of a spectrum can be given in a shorter time with reasonable price. Yeah, how do you address that issue?
I can start because we are the ones paying the price. So, yeah, but what I see, I mean, I was speaking here quite for the European situation. We see that this issue is turning. I mean, looking forward, there are some 500 licenses running out in the next years in Europe, and they all need to be re-auctioned. And the question is, how useful is it to re-auction spectrum that is widely, nationwide deployed and used, efficiently used, and to repay a tax to the state budget just for the usage? And I think this discussion is going on. We have the DNA in Europe at the moment that is discussing that. We are thinking about going into an indefinite licensing system like the US have already. And we are talking about paying more with rollout obligations and network build instead of financing state budget. And I think that's a good idea that we come there. We've spent so many billions that went anywhere into completely different sectors and so on. So keep the money in the industry to build the infrastructures would be a good idea forward, and maybe end this vicious circle of re-auctioning the spectrum all the time.
David, like?
I guess there are a couple of things. One, with the millimeter wave auction, and again, looking at Upper 6 right now, a change from national licenses to more high density area licenses. Still national in terms of, though it's still to be determined on Upper 6, but on millimeter wave, it was still a national license, but it only covered the high density areas. The other areas were left to a more local licensing mechanism because of there not being excess demand. I think on the pricing side, the UK has a slightly mix between the US and I guess Europe. They're perpetual licenses, but after the initial term, there's a trailer fee, so to speak. And those trailer fees, we just went through a process that adjusted them downwards by about 10%, reflective, I think, of that next increment of spectrum being less valuable. The last auction we did, significant price reduction, you may have heard yesterday, between what we did at 3.8 to 4.0 and 4.0 to, or sorry, our two segments of auctions in Canada, but also in the UK. We did a 2-segment 5G auction and saw a significant price decrease for the second one. So I think you just have to avoid artificial scarcity, I guess, when you go to the auction, and that affects the pace at which you auction. Maybe Chantal.
It's always a difficult question, and since all my operators are in the room, I have to be careful. It is always a difficult thing. So we're very similar to the UK in that we do have an auction. You pay at the auction, then you pay a fee afterwards upon renewal, and renewal is not necessarily automatic, but we consult on renewal. I would say that we've been trying to find the right balance. Can I say that we've always found the right balance? No. But not to say that we did it wrong. So nobody quotes me on this. Maybe I'm speaking on behalf of Chantal right now. The artificial scarcity is a big issue, but also it does take time to make these bands available. So sometimes it's going to look like artificial efficiency. So we have been criticized with respect to the 3,500 and 3,800 auctions that went back to back. We tried to manage that as much as we could. And we tried to make as much information available as possible so that operators, when they were going into the 3,500 auction, they knew it. But that being said, people bid on spectrum, and there's not much we can do about that.
Yeah, time is ticking, but can I get additional 10 minutes then? 5 minutes? Okay. Okay. Very often we hear from the spectrum economists that they talk about the technology neutrality and the investment certainty, two options. So two things we always listen from the spectrum economist. But does it really work because sometimes what happens, like we give spectrum for 15 to 20 years and license, and then we found that after 10 years, the company is no more exists. So in 6G cases, because it is not only that the license used, but there will be some other complementary technology as well. So how do you see the future licensing mechanism for the future? We do have similar kind of a long-term license in the aim of the technology neutrality and investment certainty, or we go for a different model. We have some example in Asia, in Japan or in China or Korea, different kind of model where technology adoption is much faster than other parts of the world. So how do you see that aspect from industry or from the regulator or from anyone from the floor?
Well, I'm conscious of the time, so I'll be very brief on this one. I think that it's reasonable for regulators to look at efficient use of spectrum
Yes.
as a factor in assigning spectrum. I think I'm primarily thinking about it in the satellite context, that satellite operators are assigned spectrum, large blocks of it for free, and they can hold it for very long periods of time as technology continues to develop. So one of the things that I remember when I was at the commission, we talked about this, about trying to factor in efficient use of spectrum as a factor in assigning it, to make sure that there's the flexibility for new entrants, for sharing potential down the road, not necessarily to require sharing in the immediate term, but to preserve the flexibility to have that option.
Yeah, correct. So do you conduct like the spectrum auditing, the use auditing, or in the regulator? Is there any practice to do such kind of activities?
Yes, we monitor the spectrum and how it's used, and we recently put out a policy to look at unused spectrum and make that available through a licensing process. I think to the original question, it's a mixture of types of licensings that we need to make available, and for it to be the right size of licensing for the right issue.
Yeah, I think the challenge, I think, is the principle that you should use it or relinquish it or share it or various variations of that's well understood. The hard part is often measuring the use or measuring the efficiency. And those metrics change over time, like they're not static, but because of our legal frameworks, we consult on them. So, the metric you might have set for, say, satellite efficiency today is probably not the same one you need 5 years from now or 5 years after that. So I think the desire is great. The implementation is still work to be done for regulators and the industry, I think.
Yeah, so we are at the end of discussion. Any comments, questions from your side? No? Okay, I think we need to continue discussion because next year we do have the WRC, and then once the frequency bands are identified, then we need to continue that discussion work for IMG 2030. So maybe next year again, we may come back for discussion on the same topic because it is evolving. So we need to keep in touch on that. So with that, I would like to conclude this session, and then please.
Yeah, thank you so much to our panelists here, and Parvez, thank you very much to you again for guiding us through that discussion. Another really interesting session. And as Parvez is up here, maybe I just wanted to mention briefly the papers that you all have on your tables in front of you. So Parvez and his colleagues at APT have launched a Friends of Spectrum portal, which is going to be a portal that has resources, it has a mentoring system as well, lists of events and things on that. So more information on the sheets on there. And I think it's covering Asia Pacific, but it's going to be global as well. Is that right? Global. So it's going to be a global resource for Spectrum. So please do check that out as well. So, but thank you so much to our panelists here. And thank you to all of you as well. So that just about wraps things up for this year. Did want to finish with a few more thank yous, if I can. So first of all, and most importantly, once again, I would like to say a huge thank you to ICED, to everyone at ICED, to Chantal here, and to Shari, and to all of the team. Really do appreciate everything that you've done. So thank you so much. And again, it's fantastic coming here. And I definitely can recommend coming to Ottawa this time of year. It's a beautiful city when the sun is shining, so that's been great as well. Thank you to all of our sponsors and partners. Again, really do appreciate the support of all of the partners and sponsors involved in the event. Without them, it's not possible, so thank you very much to all of them. Thank you to all of our speakers and moderators over the sessions over the last day and a half. So we've had a lot of really interesting discussions, and there's a lot of work that goes in, obviously, on the day, but in the preparation and things for those as well. So thank you all so much for everybody who's participated, both here and those who've joined us online, sometimes at very antisocial hours. So really do appreciate that from everyone, all of the speakers and the moderators here. Thank you to all of you. So we've had over 200 people here in person over the day and a half. And for everyone watching virtually, really do appreciate everyone who's joined us virtually as well. We don't quite have the final numbers, but my understanding is there's more than 500 people have joined over the day and a half from the virtual platform. And I think we had more than 50 different countries eventually who've joined. So again, it shows it's a truly virtual, it is virtual, definitely virtual, global discussion and things on that side. So thank you very much to everyone in that way. Quick thank you to the venue staff here. Venue have been great and looked after us really, really well. And to our AV team at the back there, to Greg and Jason, who have been sorting everything out with the microphones and the videos. And so thank you guys, top job on that. So thank you very much. And finally, as ever, I'd like to save my last thank yous to my fantastic team. So it's truly been a bit of a team effort this time with the involvement here. And also lots working on the virtual side back in the office. So, but we have Yayan and Ivana here at the back, who've done a fantastic job here on site. And then back in the office, we've got Ari, Jordan, Shan, Bryony, and then Josh and Anna, who've also made a big contribution as well. So big team effort. So thank you very much, guys, for that. And finally, next event. So just to let you know, our next event back here in the region is going to be our Latin America Spectrum Conference, which will be the 30th of August and the 1st of September. And as Glenn, I think he's still here, mentioned in yesterday, that's going to be in Costa Rica. So delighted to be working with Glenn and the team and to be hosting that in Costa Rica. So we'll be sending more information out shortly. And our next 6G event, we are going to be working alongside TDRA in UAE to launch a 6G MENA event, so focusing specifically on the MENA region. And that's going to be sometime in October. So more information on that soon, and we'll definitely keep you updated on that as well. But once again, thank you so much, everybody. Those of you here, safe journeys home. Those of you at home, thank you for joining us as well. And look forward to seeing you all again soon. Thank you.
Thank you.